Alrighty. Hi everyone. I'm going to quickly go over um, some triangle theorems. Um, and there's really only two things that we've learned in terms of theorems about triangles. Um, so let's continue. The first thing that we learned about was the sum of the measures of the interior angles of a triangle equals to 180. We called this the triangle sum theorem. So triangle sum theorem. All right, and that's this guy over here. And all that means is if you're given any triangle, so let's say I give you this thing over here. That's my triangle. Um, and then we say, okay, well, I'm going to tell you that this is a 30-degree angle, and this is a 60-degree angle. And the idea is, well, the only possible choice that this angle can be is whatever makes it so that 60 plus 30 plus this angle is 180. If you guessed it, this is 90. If you notice, 90 plus 30 plus 60 is 180. So any triangle that you see, you know that if you add the angles inside the triangle, that's 180 degrees. Bam. Okay. The other theorem that we learned, I will also write, and it's called the exterior. The exterior angle theorem. Okay? And all that means is, well, the measure of the exterior angle, you know what, I'll highlight it for you. This is our exterior angle. The measure of the exterior angle of any triangle is equal to the sum of the angles, and just to remind you, sum means to add. Okay. Um, the measure of the exterior angle equals the sum of the measure of the two non-adjacent interior angles. In other words, the angles that are inside the triangle that do not touch this angle. Okay? And if we want to just check that, well, 40 plus 60, when you add them together, it equals 100. Okay? So let's do a couple of examples where we might see some of this stuff. Um, so, alright, let's use my favorite color, which is this one. Alright, solve for the missing angle. So we can use our problem-solving planner. And remember, the first thing we should do is identify what our question is. And the question is solve for the question. So solve for the question. I'm getting used to this writing pad that I'm using, so bear with me. Um, the second thing is what information do they give you? I'm going to highlight it for us just to make it a little bit easier. I'm going to use this color. So we have 70. Whoa. Okay, we have 70. We have 50. And we also have this angle. Okay. And then the most important thing that you got to figure out is, well, what did we learn in class that can help us figure this out? Now, there's a couple of things we can do. We know the triangle sum theorem, that the angles all up to 180. We also know that the angles that don't touch the exterior angle, let me silence my phone, the angles that don't touch the exterior angle, if you add them together, it equals to that angle. So I'll be honest, you can do both ways, and that's what we're going to do. Bam. Bam. So, we're going to use the exterior angle theorem first. Okay. So the exterior angle theorem says, is that this angle, so this angle, equals the sum of the angles that don't touch it. So 70 plus 50. So in one step, we were able to figure out an equation to help us find for our question mark. Then 70 plus 50 is 120. Okay, so the question mark equals 120 degrees. if we want to use the triangle sum theorem, I'm just not spelling everything out, just to not waste time. Let's see if I can quickly erase everything. Okay. Um, triangle sum theorem, well, that says, well, if I add up all the angles in a triangle, I get 180, right? What if I wanted to find this angle? Well, 70 plus 50 is what? 120, right? So 70, let me write this out. 70 plus 50, I should write out the whole thing, I'm sorry, plus x is 180, right? Now, when we add these two together, you get 120. Whoa, it's the same answer, but we'll get there in a second. Plus x equals 180. And if we want to solve for x, we can subtract 120 on both sides. And you get x equals 60 degrees. Now you might be asking yourself, Mr. D'Souza, well, how does that help me? Well, what type of angle is this? It's a linear pair. So what do you know about linear pairs? Well, if you add up this angle and this angle, it equals 180. So 60 plus the angle that we're looking for, let's call it y, equals 180. Subtract 60 on both sides, and you get that y, which is our missing angle, which happens to be the exterior angle, equals 100 and, oh, I can't fit it, I'm so sorry, 20. But look, did both of these methods work? Absolutely. But which one was much easier? This one. Let's do another example. This time I'm not going to choose both methods, right? So if I wanted to find x, let's be a little bit more clever. Um, we could do this two ways, and actually both ways are equally as long. If you recognize, oh, this is a triangle, I can use the triangle sum theorem. You can do 80 plus 35 plus x equals 180, and you're done. Or I can use the exterior angle theorem, which says, hey, if I add up these two, if I add up these two, it's going to equal this one. Well, let's just do that. 80 plus some number x equals 145. If we subtract 80 on both sides, all right, what do you get? 145 minus 80 is 65. X equals 65. Now I challenge you, well, use the triangle sum theorem and see if you get the same answer. Hint, you will get the same answer. Anyways, last question. This has nothing to do with the triangle sum theorem or the exterior angle theorem, but it does have something to do with bisecting. And what bisecting means, this word, you can always replace this word with to cut in half. Okay? And this was a question just to kind of get you used to marking up your diagram. So let's do that. I'm going to choose a different color. Let's choose this cool color. Okay. In the diagram below, line FE cuts in half AC at B. So FE cuts in half AC. So this line, FE, cuts in half AC. So if this line cuts this line in half, that means this piece is congruent to this piece. Awesome sauce. Let's continue. And then it says GE cuts in half BD. So GE, this line, cuts in half BC. Well, that means this line is congruent to this line. Well, what that's saying is, well, let me actually highlight. That'll be a lot easier. If this line is congruent to this line, right? And this line is congruent to this line, then aren't each line segment congruent? Yes. So, let's see. Is AB congruent to DC? So is AB congruent to DC? Yes, because we just came up with each of these line segments are congruent. Um, and the vocabulary word, if you remember from class, is the transitive property. Okay, I hope this helps reviewing some triangle theorems, triangle sum theorem, exterior angle theorem, all the theorems. Um, have a great rest of your day.